Hi everyone, is it audible to all?
Yes.
Okay. So yesterday, just a 2 minute summarization of yesterday's class. So we were looking into naive-Bayes algorithm, so which is purely based on this particular like probability formula. So it is again known as Bayes theorem. Okay, so based on that we are looking into naive-Bayes, and if we see what we had covered yesterday, so. It is like, let's say we have some email. There are some 10,000 emails. So what we are doing is we are trying to classify those email into two categories. Okay, one is spam and one is ham. So how to classify using naive Bayes? So few of the example, like the underlying principle, how it is doing is to all the textual data. The first step it is converting all the textual data to a TF-IDF matrix format. Okay, so the rows of the matrix are nothing but each unique word present in the entire corpus, and the column of the matrix is nothing but each email. Okay, then if the word is present, let's say free, this is a particular word. If that particular word is present in the email, then it is the value is 1, otherwise 0. Similarly, finally, we will be getting a 0 1 matrix. Okay, so all the algorithms are applied on that matrix, converted matrix. Okay, so this is the step number one. So as a programmer, no need to do that, like matrix creation and all. There is a package, we will simply call that package. But the what the package is doing, the package is doing nothing but that is known as counter vector package. Okay, I'll tell you while showing the program. So what that will do, that will again, how to calculate this free registration going. There is one class, natural language processing class. There we are going to see how we are formulating and how we are applying machine learning algorithm, especially for textual data. Okay, so the first step when you are applying machine learning on textual data is nothing but um, token. You have to convert the entire text into token format. So see, this is the entire text, right? So token format in the sense what, you have to split on the basis of space. You have to split your data. If time permits, today also we can see one of the such algorithm. So the first step is split the data. Okay, so after splitting, the entire text will be converted to tokens, right? So free is a token, registration is a token, going is a token, all these are tokens. We converted it to tokens. Now we remove all the stop word. What do you mean by stop word? Stop word is most common occurred word, like hi, the, is, all the preposition, articles, these are highly occurred language. We cannot take that as a unique word, right? So we'll remove all those stop words. Rest what we get, that those all are, we will, let's say free has been occurred 20 times. So free inside, there will be a reference how many times it has been occurred. So that is 20, right? So this is one way. Second way is if you sum all the row, right? Free. This is the free, right? What is the occurrence? 1 plus 1, 2 plus 3, 4, like that. So where how many ones? Those many occurrence of particular word, right? So this is the this is the way how naive work. And what are the pros? The pros are it is very easy and fast, and it's good for multi-class prediction. And the uh, cons is it is zero frequency error. Okay, now let's deep dive into programming. We have seen that yesterday. So first, we what we are doing, as we have done, like importing all the packages here. Till here we are importing all the packages, and then what we are doing, we are defining a function. Okay, so from here to here we are doing nothing but we are defining a function. Okay, here to here we are defining a function which will read. The function is in this format. Let's say mail is one folder. You have, once you download, you will be getting in this format. Mail is the folder. Inside that there is again two folder. Okay, and inside each folder you will be having few email. Okay, and email is again some subject line will be there, some to and from, and then the body of the email. We are not concerned about the subject line and other part. What we are concerned about, only the textual message, right? Only the body of the message. So that's what we are doing here. If you see, it is nothing but simple Python coding. So what we are doing, we are simply where is it, message. Yeah, so here we are checking if the message is in body, so then we are joining those things. Okay, so this function at the end of, once you call the function, what it will give you, it will, what it is returning, yield path message. So it will yield the path where the particular email has been there, and with that it will return you the message. Okay, message in the sense entire textual data whatever is there. Now we have another method, user defined method. Okay, this is user defined method number 2. What we are doing in this method, we are converting this message. Here we are getting path and message, right? So we are converting this message into two classes. Okay, one is like message, and two, not two classes, two columns of a data frame. One is the classification, I mean which class it belongs to, whether it is a ham or it is a spam, like which class is belongs to. Okay, so finally this method, what it will give, this is a user defined method. What it will give, it will convert into, or maybe the entire data it will convert into a data frame with two column. One is message column. Okay, and where the email will be there. Okay, the body of the email will be there, and the class column. And what will be the class? Class is nothing but whether spam or ham. Okay, so each email message, and then it belongs to which particular class. Okay, similarly again next email, it belongs to which particular class. So we are converting it, the raw data we have here we got the raw data. Okay, and now we are converting that raw data into a data frame with two columns by this method. Okay, so now what we are doing, so yeah, so fine. Now we are clear with the two user defined function. Now what the next step is, calling those functions, and yes, so now what we are doing is, here data equals to data frame message, message classes. Here we are defining a empty data frame. Okay, and one time we call the function, one row will be added. Next time again when we are calling this particular user defined function, another row will be added. Like that we are going to add each row in the data frame incremental order, in a incremental order. Okay, initially we are creating a, it is nothing but all, it is nothing to do with machine learning. Okay, whatever we are seeing till now is nothing but the pre-processing steps. Okay, so all these steps you have to design when you are working in a real life project. Okay, so you have to design all this pre-processing step. Now in this empty data frame we are appending data frame, we are calling the function. Okay, we are calling the um, user defined function, and we are passing two parameters. One is, see what is the input to this function, one is the path and one is the classification, these two, right? Classification folder, I mean which classification. So we are passing two things, one is the path and second is the classification, what we want, spam or ham. So as I told you, inside the inside emails. Okay, so e drive, in e drive emails is the folder. Okay, inside emails there are two folders again, spam and ham. Inside each folder so many emails are there. So we are giving the path, and then we are giving the class, which class that particular, all those emails which are present inside this folder belongs to spam class. So we are passing that. So again here from, okay, so from here it will call to this user defined function, and finally what it will return, it will return a data frame. Okay, so similarly we are creating two data frame. Data we are like with the same data we are appending all the emails in this format. Okay, so all this now, all this thing what we have done, we have created a data frame now from the data, right? Now we can apply machine learning techniques. So now what we can do is, as I told you, so we are applying multinomial naive-bayes classifier. If you remember, I told you yesterday there are three types of naive-bayes algorithm available in scikit-learn. One is multinomial, one is Bernoulli, and one is Gaussian. Okay, but we are using multinomial here. So there is a fit method which can be used for training, and then before training there are few pre-processing steps, as it is a textual data. So as I told you, to convert it, to tokenize it, to remove the stop words, and then to convert it to a TF-IDF matrix, then to convert it, once you convert it then you can apply. Okay, so to do all such steps, what you are doing is you are calling one function known as counter vector riser. Okay, if you see the packages, when we are importing packages, no, we are importing one particular package. I'll let you know what exactly that package is, which is, yeah, so we are importing the counter vector from sklearn feature extraction dot text import counter vectorizer. Okay, so we are importing the counter vectorizer package from sklearn. So what that package is doing, that package is doing nothing but whatever I told you, all the pre-processing steps it is doing. Okay, so similar way we are first creating an instance of counter vectorize. Vectorizer is nothing but the instance, and using that instance we are calling the fit transform method, which will be applicable to the data frame we have, right? So the data message column is nothing but the email textual data. On that we are applying the fit fit transform method. Okay, so now it has been, what is counts? Excuse me. So counts is again nothing but the TF-IDF matrix, the numerical format, the numerical representation of the emails. To each email, we are representing it into a numeric format in TF-IDF matrix format. Okay, so we will not apply algorithm to the data frame. When we are calling the fit method to apply machine learning algorithm, we will be applying the method into counter. Okay, now the third step is call the multinomial naive-bayes method, and then what you can do is you can call classifier dot fit. Classifier is nothing but the instance. Classifier is nothing but one instance of naive multinomial naive-bayes, and by calling that instance here dot fit methods, we're passing what are the input. Count is the input. Okay, always remember the input should be in a TF-IDF matrix format. So counts is the input and target is the out with which we are training output, right? So fine, so our model has been trained. Now you can see here multinomial alpha equals to 1, class prediction non, fit prior true. So we our model has been trained. How to use that model? Okay, so now we got our model. How to use that model? Let's take an example. Let's take these two new text email. Okay, let's say these are the new text email, and we want to apply naive-bayes algorithm to predict which particular class these two particular emails are belonging to. Okay, so let's say the first email is free Viagra now. Okay, and the second is hi Bob, how about a game of golf tomorrow? So by reading these emails, it is pretty clear that, or maybe reading this text data, it is pretty clear that the first one, free, must be something related to spam, And the second one, how about, because it seems to be a personal message, so it cannot be a spam, it should be a ham, right? So let's see how the model is like predicting, whether it is correctly predicting or not, how accurate our model is. Okay, so we, one second. So check your example count the same way we are testing our model. So vectorizer dot transform example. The step number one, as I told you, this textual data, the algorithm cannot applicable. So we need to convert it to a mathematical form first. That's the reason we are calling vectorizer method dot transform method. And we are transforming all these examples into a numeric format, right? Now we are calling the predict method as we called or in all other algorithm, right? Fit and predict. So we are predicting, we are calling the predict method, and the input to predict method is example counts. Okay, it is not examples, it is example counts, which is the input for this predict method, right? So prediction is the output. Okay, what it contains? It contains the class which this particular messages belongs to. So if we print the class, you can say it is a array. So so the first is a spam and the second is a ham. So it has been predicted the class spam for this and ham for the second message. So I think it is correctly predicted, right? So what you can do is, once the class is over, when you're going back to home and you're practicing, what you will do is, here instead of this particular two messages, you try keep changing some other messages of your choice. Okay, give some messages which you think will be a spam, and give some example of ham message, not only two, you give some 10, 15. Okay, here, and then call the predict method and try to see what all classes it is predicting. Okay, so this is how generally we are implementing, this is one of the application of machine learning. So Google, if you see Gmail, automatically your emails are getting converted into spam and ham, right? So this is the algorithm, this is the logic they are using. Okay, so this is one of the algorithm of machine learning classification. So now we will be seeing any I need someone machine to showcase the output, but before that I just want to let you understand. So we are going to jump into Spark, and we will be seeing two programming on Spark. One is decision tree random forest, and SVD we are going to see. Okay, SVD is nothing but one of the dimensionality reduction technique, and it is known as singular value decomposition technique. And again, one of the example of SBD is ALS, alternating least square. Okay, so it is, you can say, one of the one of the derived algorithm from SVD. So we are going to implement ALS today, alternating least square. Okay, so I don't want to waste much time on only theory. So the theory of for ALS is well explained in this video. This is like artificial intelligence course of Coursera. You can take this course also. There is a module known as collaborative filtering module. Okay, so the professor is the founder of Coursera, Andrew Ng. Okay, so he has explained everything very nice way. You can check the mathematical derivation, you can check here. Okay, finally, the optimum, the what we are doing again, ALS is very heavily used for recommendation. If you remember, in the recommendation class we have seen user similarity based recommendation, right? ALS recommendation we have not seen. I told you, if you remember, the model based part we will implement using Apache Spark, right? And the memory based technique, user similarity and item similarity, we had implemented using Python. So the model based approach is ALS alternating least square method. So what exactly it is doing? Let explain you few theory part first. Okay, so the entire data, okay, your entire customer data is finally represented in a matrix format. Similar to name base, we are representing it into a matrix format, right? Entire text. Similarly, here the entire customer data we are representing in the term of a matrix, if you remember. Then what is the matrix row? Row are nothing but, let's take the example of say movie lens data set. So there are few movies, and you are there are few users who are giving rating to those movies. So the rows are nothing but the movie names, and the columns are nothing but the users. And the value of this matrix is nothing but how much rating you had given to that particular user. Let's say the scale is 0 to 5. So how much rating you are giving to particular movie, that particular user, how much rating he is or she is giving to the movie. And the question mark is nothing but if he has not seen the movie, means he has not written given any rating. So our problem statement is to predict all these question marks. Okay, so the problem statement is Elias has seen love at last, romance forever, and what is the value, or maybe how much rating Elias will give? Can you predict how much rating Elias will give if he will see cute puppies of love? Okay, so this is the question. We are going to, the algorithm is going to predict all these question marks. So all this unseen movie, if I give you recommendation to see how much you like, how much you will give rating, that's what I am predicting. And if it is predicting very good, let's say if I suggest cute puppies of love to Elias to watch, let's say it is giving 5 rating. Okay, let's say the system is predicting 5, means what, there is a high chance that you will like the movie. So I will be giving recommendation to all the 5-star movies to you, right? This is the common funda. Okay, so now after applying machine learning techniques and all, we are getting two vectors. Okay, the ALS will give you two vector ultimately. Once you apply machine learning ALS technique on this particular matrix, okay, so you will be getting two vectors. One is user vector and one is item vector. Okay, so again, user vector, item vector, what exactly that is? That is pretty similar to a, excuse me, it's pretty similar to a numeric formula vector, right? So one second, let me show you the formula. So it is very well explained. Okay, you can check. So theta 1 is nothing but we are for each user we will be getting one user vector. So what exactly we are doing here? So if you see this entire 10 minutes video, the like theory part will be very clear. He has explained how we are getting 1 or 0, how we are exactly getting how much rating, or maybe how the user vector item vector has been generated. Everything this he has explained very clearly. Finally, the optimization algorithm is this. Okay, so this is the optimization algorithm for ALS. What we are doing, if you see, there are two parts. One part is this part, before plus symbol one part, after plus symbol another part. So we are using a iterative, this is a iterative algorithm. ALS is a iterative algorithm which tries to solve this particular equation in a alternative way. Means what? In iteration 1, it tries to optimize the first part of the algorithm. Okay, first part in the sense this part, before plus symbol. In the second iteration, it keeps the first part constant, and it tries to resolve the second part. It tries to optimize the second part. In third iteration, again it keeps the second constant and tries to resolve the first part. Similarly, in this way, we it goes and it try to optimize not for one, not for two, but for millions of iteration. Maybe 10,000, 20,000, 50,000, 1 lakh. Okay, 1 million, 5 million times we have to iteratively run the algorithm, so that finally after so many iteration, in one particular iteration the algorithm will be optimized. Okay, and we have to stop there. Fine. So based on that we have some parameter. So how this equation is and what about all the details of the equation, from this video it will be very clear. He has explained. Okay, so how exactly the algorithm is working, and like, so just go through this. It's lots of mathematics involved. I don't want to deep dive into that. So this is hardly 10 minutes time, so I think you can go through it. Okay. And there are some,
Sasmita,
yeah.
so in the model based also we have two types like user based and item based.
See, mm, to be very frank, in model based there is no two types. Okay, so if you remember, in memory based there are two types because it is based on similarity. So if you are trying to find out who are the similar users of yours, that is user similarity. And if you are trying to find out which are the items similar to your items, that is item similarity. But here there is nothing to deal with user and item. The main concept is, let me show you. Okay, we'll come here again. The problem formulation, let me show you what exactly we are doing. So this is so many, I don't think you will find any difficulty in getting ppts. 100 millions of ppts available, but still if you want I can give you, uh, take this ppt, I will show you any ppt is fine. So see what exactly the agenda is. These are the users and these are the particular movies. Okay, they had given some ratings just now we have seen, right? So this is the problem statement. So he has not seen this movie, so the I will apply ALS, and I'll try to find out if this user is watching this particular movie, what is the rating he is going to give, right? There is a problem statement, right? So now, um, how we are going to resolve it. This matrix is very heavy matrix, right? So the dimension of this matrix is nothing but number of users multiplied by number of movies, right? So because number of users is nothing but number of rows, and number of columns are nothing but number of movies. So just imagine if if you represent a website like Amazon in terms of this matrix, then can you imagine how huge that matrix will become? Some terabyte of space it will take, right? Because there are some billions of users for Amazon, right? So for that reason, if you apply any of the machine learning technique, it will be very heavy computation. So much time it will take. Again, we are running the algorithm for 1,000 or maybe 10,000, 20,000 iterations. So it will take so much time, which is not possible in real time. So that's the reason we are using dimensionality reduction technique to reduce the dimension of our original data. And one of the dimensionality reduction technique is SVD. Okay, which is nothing but again singular value decomposition, which is a matrix factorization technique. If you want to explore more, just go to Google and type matrix factorization algorithms. You will be getting so many algorithm list. Okay, so one of such algorithm is SVD, and one of such subcategory of SVD is ALS, alternating least square. Why it is alternating least square? Because I have shown you the optimization algorithm, right? Optimization formula. So alternatively, it is trying to uh, optimize one part of the equation, and then keeping the first part constant. Again, it is trying to optimize the second part. So alternatively, it is doing task. That's why it is alternating least square algorithm. It is known as. What we are doing, the entire matrix, we are converting that entire matrix into two small matrix. Okay, so this again, as I told you, this red color matrix multiplied with this green color matrix will approximately equivalent to this sky color matrix, which is nothing but the original matrix. So if you multiply the small two matrix, it will give you equivalent, not exactly 100% similar, no, because there will be some data loss while conversion. Okay, so mostly it will be equivalent to the original one if you multiply this two. So now this red color is nothing but user vector, and this green color is nothing but item vector. Okay, so user vector is nothing but a numerical vector. If you want, you can, once you apply, no, once you go to coding, you can see you can even print the user vector and item vector. Try to print and see what exactly it contains. It contains nothing but a vector of so many numeric values, 0.5, 0.1, 0.2, like that. Okay, so right, so how many so here this particular user vector and item vector, so we are all doing our operation in this data, not in the original data. Okay, we are reducing the dimension to this format, and then See, again, ALS algorithm is not only used for recommendation. One of the application of ALS is recommendation, right? But we can apply so many. There are so many hybrid recommendation also. So what I did is, like in my master's day, in on top of this user vector, again the output of this ALS, I had given input to K-means algorithm, some other machine learning algorithm, right? So which took input this user vector. Okay, because I'm very much concerned about user similarity clustering, so I have given this user vector as an input to k-means algorithm. Okay, and finally it the k-means algorithm uh, s- find out the similar clusters of users, right? So many hybrid recommendation also you can design of your own. So main agenda is all this dimensionality reduction techniques are pre-processing techniques. The output of this dimensionality reduction techniques can be given input for other machine learning supervised or unsupervised classification or regression model techniques. Okay, so the agenda is convert the entire matrix into two small vector format matrix, and the multiplication of these two should be equivalent to the original one. Okay, so this is the main thing what we are going to do. Okay, so if you remember, like this is the formula which we are talking about. Okay, so again, this users are nothing but user vector, movies are nothing but movie vectors. Okay, and how we are getting this to the conversion from this to this can be done by optimizing this formula. Okay, so this is the all theory, and these are few parameters. It is very important. So when we are calling ALS method, there is a method ALS in Spark library. Collaborative filtering algorithm is already implemented in Spark ML library. If you see, if you want to check, just go to the documentation page and just go to the collaborative filtering part and just see. Okay, this is the only one algorithm present in collaborative filtering. Because why? Because all this user similarity, item similarity is not fitting to big data. We it cannot all day all algorithm cannot be uh, very well suited for big data platform, right? It cannot be parallelizable. All algorithm you cannot write in map reduce format. So that's the reason few algorithm we need to skip. So user similarity, item similarity, this is taking huge time. So for real time analytics, it is not for huge data set particularly it is failing. That's the reason in 2009 the SVD approach, ALS is nothing but the winner team of Netflix prize. Just Google Netflix prize 2009. Okay, so they have discovered this method, ALS method. Okay, and they improved the accuracy of Netflix recommendation engine by some percentile, and they got a huge amount of award for that. Okay, from 2009, it is a very new technique. It has been discovered in 2009. Okay, so after that, entire recommendation engine industry changed. Everybody nowadays is using SVD ALS algorithm. Nobody is using, very rarely they are using. If it is very less data set, then they are using similarity algorithms. So when you're calling ALS method of Apache Spark, what are the parameters you need to pass? Okay, that is the question. So the parameters that we need to pass is, number one parameter is number of block. Okay, is the number of blocks used to parallelize computations, right? So number of block in the sense how many number of block you want to pass, that is one parameter. Rank is the number of latent factors in the model. Okay, rank, what exactly rank? Rank is like how many factor you want. Okay, 2 factor, 5 factor, 10 factor, 10, 15 factor. So entire data will be converted to a 15 factor model, right? So rank is nothing but how much factor you want. Iteration, as I told you, how many number of iteration you want to run. Lambda specifies the regularization parameter. If you see the algorithm, so this is the lambda. Okay, so this is the lambda, and we are giving the lambda here, the value. When we are calling the ls, we are passing the lambda value. It is nothing but optimization parameter. Okay, So regularization parameter we are giving when calling the function, ALS function. This is one value. Implicit preference specifies whether to use the explicit feedback ALS variant or one adapted for an implicit feedback data. So what is the difference between implicit feedback data and explicit feedback data? For example, here in our movie lens data, it is implicit feedback data. Why? Because we have the rating. Directly we are having the data. Sometimes in other websites, if you go to some movie website, sorry, uh, what radio websites like Pandora, okay. So if you go there, you will be there is no rating, right? Um, so what you will be getting? How many times you have listened to the particular song? Based on that, I can decide whether you are liking that song or not. There you are not giving any ratings. So let's say one website there is no rating facilities available. So how you can judge, how you can find out the rating explicitly? Implicit rating is not there. How you can find the rating explicitly? By finding the one of the approaches. There are so many approaches how you can find one of the approaches by seeing how many times you have listened that song. Let's say you had listened that song more than 500 times in particular 6 month duration. It means definitely you're liking that song, right? So I can give a high rating, right? So I can write an algorithm which will convert the explicit feedback data to implicit rating. Like what? Count the number of times I listened. If it is greater than 400, give a rating 4. If it is greater than 200, give the rating 3. If number of times I listen the particular music is 0, I have never listened, then that is a prediction algorithm for me. I need to find out if I give the new song to you, how much you are going to like. And let's say I have listened only once and never listened twice the particular song, then I it's very clear I am not liking that song. In that case I will give a rating 1. So here what you are doing, you are converting, you don't have implicit ratings. By seeing the customer behavior, by seeing the customer history, you are finding or you are converting the explicit data, explicit feedback data to ratings, right? In that case it is known as explicit feedback. I hope it is clear. So in ALS module of Apache Spark, you have also option to choose whether the data you are using you got implicitly or explicitly. Okay, so implicit prefers specifies whether to use the explicit feedback or one adapter for implicit feedback data. Okay, and what is alpha? Alpha is a parameter applicable to implicit feedback variant of ALS and governs the baseline confidence in preference observation. So if your data is implicit, okay, um, then you can use, sorry, explicit is like which you get, okay, implicit is like which you derive. So if you are deriving, then you can use the alpha parameter. Okay, so these are the few things you are passing when you are calling the ALS method. Okay, if the performance is not good, what you can do is go back and try to change few of the values for this parameter and rerun the program and see the performance whether it is improving or not. Okay, so this is again only the theory part. Any this you can get very easily from internet. The main thing is to understand. Okay, theory and resource you can get from internet, no worries. Okay, so if you see here, basically the particular sparse matrix, all many rows, many things are blank here. It is converting it to a dense matrix. So this is the user vector, this is the item vector. Okay, so we have a data just for your look, like this is the data user item dot txt. So it is a comma separated value. You can see user ID, item ID, and the rating. The third column is rating column, how much rating he has given to that particular item. Okay, this is our data set. We are gonna work on this data set. So this is the program. Okay, so I am going to transfer. Maybe I will upload the program today. You try it on your own machine. I was thinking of doing I mean, coding it in front of you by taking a few of your like system sharing system control, but I think time will not permit us. But anyway, I will explain this very well. Okay, and what you can do is go back to your home and try to implement this on top of Apache Spark. Every time you are running any of the Spark coding, the step number one will be uh, to to call the setup file, to run the setup file. Okay, so run the setup file in the sense, I have told you right in the last class, setup.py. Always you have two option. You can run that set, copy paste the coding of the setup file in a new file, and then you start, because we are going to use the sp context, right? And maybe spark session sc s all this spark context spark session, which is nothing but the driver program. If you remember, we had designed in the setup.py file, right? So each time you start the program, writing any program, you can copy paste the code in that particular file and then write your own code below to that. So what we are doing here, see, the first step is loading the data, right? So the data is this. If you remember, this is the data, user item data just now I showed. The step number one is loading. Okay. So in Python, the first step is loading the data and converting it to data frame. So now we are loading the data. There is a method known as text file. Okay. So if you use if you remember RDD concept, right? I told you we will see how to create an RDD. So one of a way to create an RDD is, there are several ways from existing data structure, like from a list, from a dictionary, from any existing, from a data frame, you can create an RDD. Second way is from any text data. Let's say your data is in text format and you want to store or you want to load the data into an RDD. That's way also you can create. So when it comes to text data you want to load, there is a method, okay, known as text file. Whenever you are calling this method, always remember the data will be stored in a RDD. This is the way how we can create one RDD. Okay, so text file. Okay, so this is the method text file. Okay, so what we are doing, using the sp context object, always we have created, right, driver program object sp context. Using the sp context object, we are calling the text file method and we are passing the data, user item data, .txt. This is the data we have, we are passing that. So ratings data, what is ratings data? It is nothing but an RDD. Okay, so we had stored the textual data into an RDD. This is how we can create an RDD, by calling the text file data, right? So then what we can do, we can collect. If you remember, collect is nothing but one of the action. There are two things, transformation and action, I told you, right? So until unless you are applying any of the action, nothing can be performed. So it's better every time you load the data, you call one action function to check whether your data has been properly loaded or not, right? So collect is nothing but, it will collect the result from all the slave node and it simply prints the entire result on your console. Okay, so rating data dot collect will do nothing but will print the entire data set for you. Okay, which is nothing but in a RDD format. So this rating RDD, entire rating RDD which holds the entire data, will be printed. If it is giving you some output, means it is pretty clear that your data has been loaded properly. But if once you call the collect and you are getting some error, so error in the sense rating data could not found, some error similar to this if you are getting, means there is some problem in step number one, right? The data has been not properly loaded. So you need to check your coding again. Okay, so like that way, the first step is that, and then what we are doing, we are applying a lambda function here, and what we are doing, uh, rating vector equals to rating data dot map lambda 1, what we are doing, 1 dot split. So if you remember, lambda function is very beautiful function of Python. So it is, if I have covered lambda function, right, when covering function chapter for you, had I covered?
No,
No.
Shashmita,
Yes. Yeah, you're asking, yeah, you have some doubt?
no, I'm asking like we did not cover that.
Okay, okay. So what, see, lambda function is again, if I have not covered, I will take some time to cover it. It is pretty important, and 80% of the MapReduce code, okay, or maybe Apache Spark code. Apache Spark code is not exactly only about MapReduce. We are applying so many other transformation action here. So in Hadoop, if you are using Hadoop, if you're a Hadoop developer or maybe analytical platform, if you're using Hadoop, all the code you need to write in only in map and reduce format, but it's not the case with Spark. It is much more flexible than that. So 80% code you can write if you are very clear about lambda function. Okay, so what exactly this lambda function is? If you remember in Python, normally function we are defining using def keyword, right? Def, then we are writing the function name, we are passing parameters, and then a semicolon, sorry, then a colon, and then you are writing the body of the function, right? So this is the normal way of declaring a function. But lambda function is otherwise known as anonymous function. Okay, what exactly it is? A function without a name. Okay, so when it comes to very light operations, let's say our code is only one or two lines of code, right, which we are writing inside the body of the function. So instead of writing so many lines, we can write it in one line. Okay, so take an example of addition. Okay, let's say I have a function def of addition. Okay, this is the add function, and inside that, uh, let's take here I am passing two parameter, let's say a and b. Okay, and I am particularly doing nothing but a plus b I am doing, and I am returning a plus b. Okay, so this is the function. This is a normal way of defining a function. What is the same lambda way of defining the same function? What we can do is, okay, the lambda function starts with the keyword lambda. Okay, so it is not only for Python, in Java, in Scala, in everywhere this concept is there. Okay, in Scala it is known as inline function. Okay, so lambda of, let's say, a and comma a comma b. Okay, lambda of a comma b colon, and then the left hand side of the colon, always I need to write the variable names, okay, which on which I want to apply. So a comma b is I mean the variable on which I want to apply the logic, and the right hand side of this colon, I will write the logic, what I will do to this variable. What I want to do, I just want to do a sum. Lambda ab equals to lambda a comma b colon a plus b. So all the particular items of the data set, okay, if we apply lambda function, then each particular item, it will be applicable to each particular item. And the logic is pretty simple. The left hand side we are writing the variable names, and the right hand side we are writing what we want to do with the variable, or maybe the logic. Okay, going with this concept, if you see here, we are applying leave about map. Okay, see the lambda. Okay, what we are doing, lambda, again we are defining a function to each particular item. What we are doing, we are calling the split method here. Okay, split on the basis of comma. So if you remember, the data is like comma separated data. So the first step is to create an RDD. The first step is to split the data on the basis of comma. So we are defining a lambda function which is nothing but splitting the data basis on comma. And we are calling the map. What do you mean by map? So map of some function, we are mapping the particular lambda function to each element. Okay, we are mapping the particular lambda function. So let's say this is the lambda function, and I call it inside a map, means what, we are mapping this particular lambda function to each record, each element of the RDD. Each element in the sense each line. If you remember RDD, this RDD which we created, ratings and data, is nothing but the entire data set. Each element refers each particular row or each line, right? To each line, we are applying this lambda function. We are mapping this lambda function to each line of the RDD. So if we apply, what will be the result till here? It will be tokenized, right? On the basis of comma, we will be getting three values: user ID, movie ID, and ratings. It will be tokenized. Now we are applying another map function. So it is like a advanced level of programming way. Instead of writing the code in different lines, all the codes you can merge in one line with this period operator, dot operator. Okay. Now in this result, once we split it, we are again applying another map function. We are again applying another lambda function, and we are mapping it to each element. What is that lambda function? Let's see. So to each element L, what we are doing, we are converting it to integer and float type. If you remember this text file, when we are calling this text file method, doesn't matter what kind of data we are having in this particular data set, everything will be converted to string format. Okay, so the data type of all columns of this rating data is string, but we don't want string, right? So movie ID should be integer, a user ID should be integer, and the rating can be a float. So once we are splitted our data, here we are doing nothing. In the last step here, we are doing nothing but converting it to respective data type. Okay. So after rating vector, we are getting a vector here. The rating data we converted to rating vector by splitting it and by converting it to the proper data type. Fine. Now what we can do, after this step, we can convert that and store it into a data frame. Now it is ready to store in a data frame. So there is a method known as create data frame method. Like in pandas, you have pd.read csv method and other methods to convert into a data frame, right? Similarly, for Spark, there is a method known as create data frame. Okay, so whatever value you will be passing to that method, it will convert everything to a data frame. So we are calling that sp session, Spark session. We are calling dot create data frame. It is a method of sp session. Sp session, you'll be getting all releases 2.0 onwards, you'll be getting sp session. So we had created two objects, right? One object of Spark context, one object of sp session. If you remember last class, set of file. So we are calling that sp session object dot create data frame, and we are passing, what we are passing, rating vectors which we created here. This particular vector we are passing, and with that the name, column names. Okay, so it is pretty similar structure to pandas data frame, right? When we are creating a data frame, we are passing two values. One is the column name and one is the value of that columns. So this is how we create it. So rating df is nothing but a data frame. Now what we will do is we are going to import the ml library of recommendation, import ALS algorithm from the ml library. Okay, and then we are calling this ALS method, and see here we can specify. I have shown you the list, right? What parameters we can specify. If you don't specify anything, all it will run with the default parameters. If you want to, particularly if you want to specify, you can specify rank. I want 10 or 5 or 2, how much rank you want, how many iteration you want, all these things you can specify here while calling the ALS. So we are creating we are importing, then we are creating an object, and we are using that object ls dot fit method. We're calling the fit method on rating df, and then what we are doing, model dot user factors dot order by id collect. It is nothing but we are sorting the entire user vector. And now what we are doing, let's test our data. Okay, so how to test? So what we can do is we create a manual data frame like we have done in naive base. So let's say these are the username and this is the item. See, when we are testing, we are not passing the ratings. Why? Because we want to see how much the machine is predicting for us, because it is a like model, our model got trained, right? Now we are testing our model. Let's see how, by taking some random data to the model, by giving some random data to the module, we are checking how much the module is predicting for us. Okay, so we passed user and item, two things we passed to the module. And user is 1001, rating is this. And then we are calling um, model.transform test df dot collect, and then we are printing the prediction. So you can check the prediction. Okay, the output is not that, it is a simple script. You can run it. The prediction definitely you will be getting, uh, you can check some value you will be getting 4, 2.5, 3.5. So that is, those values are nothing but the predicted ratings for this particular movie for this particular user. So let's say user id 1001, if he watches this movie number 930, 903, how much rating he will give, that the model will predict. Okay, so again it is pretty simple way. The let me summarize it. So you have raw data in comma separated format. What you have done, you have first converted that entire data into a RDD by calling the text file method. Once you create a RDD, then what you have done, you have done some of the pre-processing before converting that RDD to a data frame. What pre-processing step you have done, you have splitted the entire data, and then we have converted each of the column data type from string to integer. And then you call the create data frame method, and you convert the entire RDD into a data frame. Once you convert it to a data frame, you are creating an instance of Spark session object. And by using the Spark session object, you are calling the ALS method of collaborative filtering and ML library, package of ML library. Then when you are calling the ALS method, you have to pass uh, parameters of your choice, like rank, regulation parameter, how many iteration you want, with all the specification you are calling. And then by once you create an instance of ALS, using that instance you are training your model by calling the fit method. Once the model is trained, okay, you are testing your model with any other new data set. Okay, and the model is giving you, if for a new if for a new movie, for the particular user, how many ratings he or she will give for a new movie or maybe unseen movie, that the model can predict. So this is nothing but this is the ALS algorithm. Okay, so I hope it is clear. Any doubt? So any doubt in this? So your task is, you have to do your homework today. So what you are going to do is, now just go and number one is, run this naive base. Okay, and try to change it. Your assignment is, I have applied multinomial naive base. Try to apply other two techniques, that is Gaussian and Bernoulli. Okay, by your own. And second step is, you can read a bit theory of collaborative filtering if you want to really understand what exactly this particular ALS like method is doing, right? The background principle. So it is nothing but I have shown you the particular uh, equation, right? We are optimizing that equation. Alternatively, we are optimizing that equation. Okay, so just see this NGU video, which will give you very good idea about the theory part. And then open your spider and try to run this program, whichever I had given. I will give you the dataset as well as the program, and try to run this program. It is and try to see the output with some other new user and movie ID. Okay, or second way is, try to find out, instead of passing randomly, you can try to find split the data into training and testing. And then no worries, how to split data in Python we will be seeing in the next class. In the decision tree we will be splitting the data into some person, and then we will be training with some 70% data, and then we will call the predict method on the test data, exactly the same way how we are doing. So big data coding is like not that difficult, right? You know, like it's very easy if you understand the concepts. Two things you have to understand, one is lambda function and second thing is all this transformation and actions. Okay, so this is what next class will be seeing decision tree random forest, and we are going to apply it on Apache Spark. With that, I'll be telling you the project details in the next class. Next class will be on Tuesday. Okay, so today is Sunday here in
So,
India. So tomorrow is a gap, and then again next class is on Tuesday. Yeah. Any doubt?
yeah, I'm about to ask that, Rashmita, is any other explanation required for lambda to read, or this is only the concept you told today?
As I told you, there are a lot of things in behind. Okay, so I will also give you few other reference, but I think Andrew NG is the best one. But if you want to read, okay, it's all your choice. So just type hybrid distributed recommendation engine using Apache Spark. Okay, so hybrid distributed, just type hybrid distributed recommendation engine using Apache Spark. You'll be getting so many. Just click on the first, the hybrid distributed collaborative filtering recommendation engine. So this is my paper only. So here few of the theory I have explained very well, but again there was a limitation, only within 6 pages I need to finish this paper. So this is freely downloadable. Okay, so the same ALS I had implemented, with that some extra other k-means algorithm I had implemented, and you can go through this paper very well. Theoretical person will be clear how what exactly this lambda function is, what we are doing, and all. Okay, so this is my.
Okay, and still I am trying to install the Spark on another computer because my this one is not working well. Still, it
Uh-huh.
has Core 5 and it's running on SSD drive. Still, the problem is still same. The problem, everything I uninstall and install again. Then also, then let's see. I am trying on another computer.
So, are you really like, are you checking the syntax? Is there any? I don't think if there is any syntactical error, then it will show you that. But the same problem I also faced. But see, I have also Googled. If you Google, you can see. So most of the answer which you are getting from, I mean, most of the solution for this problem is like the Python. I mean, the core of your system specification is not supporting, or maybe like somewhere you are missing. So there is no solution like for that particular problem. Even in fact I also tried a lot, finally did got no solution, uninstalled everything and I reinstalled it and it worked fine for me. I don't know what changes it happened. So uh, that particular error I have seriously got no solutions. Everyone is saying instead of two core, you just try to change it to one core and rerun the program. Instead of 4 GB of RAM, try to change it to 1 GB of RAM and again rerun. I tried everything, but the same error I got. So even in fact, my system specification was also very good. 12 GB of RAM it has. So I don't think specification wise it has any problem. So, but still, okay, just give me 1 or 2 day time. I will figure it out. Okay, and maybe I will tell you. I will give you 5 or 6 solutions to that particular problem. You can try each of the solution. Any one of them maybe work. Okay.
Yeah,
So yeah,
I'm trying to. I'm trying to.
yeah. So definitely, I'll ask and I'll give you the solutions. Okay. Because I am also not particularly sure about that error. The same error I also faced, and that is a Windows system. So uh, I reinstalled. That is the only way I did it. But anyway, there should be some particular reason, right, why we are getting that error. I'll try to find out the reason. Okay.
Yeah, and that setup file, I don't understand that setup file is
Mhm.
once I change the path in the setup file, whenever I try to upload again in the Spark, not the Spark, the Spider environment, is just uploading again with the same path, like my path. I'm not getting the raw one which you send me. I don't know why.
Because maybe you have saved it. So once you saved it,
Now I have two of them. One is which is the you gave me, and still it's showing the same my path. So I just don't understand what to do. So I will try again by tomorrow and let you know.
don't give the same name. Okay, give different name. Let's say you changed it and save it with some other name, set up Python for Apache Spark.py, some other name, and so there will be no confusion, right? So again, that you can, I think, resolve. Just save it with some other name and save in different directories, not in the same directory, to avoid confusion and all. But anyway, no matter where you are saving, if you give the correct path, it should work, right?
Yeah, understand. Yeah, yeah.
Yeah, yeah. Okay. So yeah, this is a theory, and there are so many other theories also. If you want to, like, I can explain it, but let me check. If you just go through it, if you have any doubt, just ask me. Okay, in the next class, this is a very easy algorithm. It's not very difficult. This particular formula is deadly easy. If you remember, if you read this particular paragraph, definitely you're going to understand what exactly this. So just what you need to understand, this parameter. So r, what is rui? Let me explain you. Okay, it will take hardly 1 minute. So one second, give me 1 second.
Hello, Sasmita.
Yeah, hello.
Yeah, Sasmita, can you just brief your project in 5 minutes, like instead of
Okay,
going to
okay,
this
okay.
paragraph?
So that will take some time. Okay, it can be taken. It will be also 15-20 minutes. So no worries. I'll explain it. Okay, my project I'll explain. So in the next class, maybe I'll explain you this entire project. I'll explain you. Okay. So this formula, everything. So what I have done, and so it will again give you a basic idea, right? How you can start your own project. So I'll explain you. No worries. In the next class, I'll explain. Okay. So Monday I'll be explaining this project. With that, I'll be explaining this for mathematical formula. You just see the Andrew ng video for pre what you can say, pre ready to the class. Then I will explain whatever uh, formula we have, mathematical derivation for this ALS, I'll be explaining you. Okay. Then we will be switching towards other things like random forest and all. So Tuesday there will be again timing, the same time we will be seeing. So morning 5:45, in between that 5:45 to 5:55, within 10 minutes we will join. It'll end by 7:30. Okay. So today you just try the naive base and try to implement ALS. Don't go for theory. Theory I'll take care. In the next class I'll explain the theory again for ALS. Okay, just try to run the code. Okay.
Smita, can you show us on the next class? Can you show us how to do it on Spark Spider? Run it maybe on your system so we can
Yeah,
see
so
it.
so actually I am planning that today, okay, so that I can finish up this name base within 10-15 minutes. And then I was actually planning to show it is in one of your system because it is very convenient for you, right? So I just want to try one by one step, or maybe I just want to show it in my system, but time doesn't permit. But I will show you the random forest, which is, see, LS is even very easy as compared to other advanced techniques. So random forest, 60 to 70% of the machine learning problem you can resolve only by using this particular algorithm known as random forest and decision tree. Okay, it is very powerful algorithm. It works for all problem, all supervised learning. I mean, maybe it is a regression or classification, any kind of data. Let's say it is numerical or categorical, any kind of data. Just blindly you can apply random forest decision tree in any data set you are getting, and that will give you good result. Okay, so that is very very important algorithm which we are going to cover in next class, and it is pretty simple. The mathematics involved into decision tree is very simple. It is the simplest mathematics as compared to other algorithm. So easier to understand, easier to implement, and very powerful, and 80% of the time you are going to use the same uh, decision tree method. Okay, so the next class is complete hands-on. So this Apache Spark I will open, and step by step I will uh, like code, and I will show you how to apply random forest and all. Okay, so maybe it will take two class, 1 hour, 2 hour, 2.5 hours it will take. Okay, so in one class I will be able to make you understand the theory only, and in the next class we'll be seeing the coding part of that. Okay,
Thanks.
yeah. Okay, fine. Yeah, guys. We can end the meeting.
Okay.
Okay. Yeah. Thank you all. And the recordings I am uploading both the recordings today.
Okay, thanks.